So both sides know each other, so our technicians know how the business processes works and vice versa. So, but let's keep it short. Yeah, we have 3 dimensions we cover. So the classical one would be the software and data and engineering part. So like pragmatic AI transformations, we also have in mind data engineering, mainframe services is also one key player. And beside that, we are also in operations and managed services business. So like today, I hope you see it. We will share the slides anyway afterwards. Today, we are covering the security and compliance assurance topic. We also have performance optimization and scalability topics, incident response and resolutions. And to complete the whole circle, to be your full-time BizTech consulting partner, we are also doing some strategy and services design. So like if you have needs in IT strategy, we also cover those to help you to being the perfect partner for all the whole IT topic in your company. So briefly about our group. So the headquarters is in Zagreb, located in Croatia. We're about 400 experts, 1,500 projects, not this year, but covered in the last 20 years. And yeah, and we are driven by Croatian engineering and German humor. That's why somebody hijacked my slide and entered something here. Well, trusted partners, yeah. So we're partner of Red Hat. We are IBM Platinum partner. We're engaged with AWS, Microsoft, the big ones, you name it. So, but this you also can read at our CROZ.net webpage. So therefore, I just saved time. And yeah, also just to name some happy clients of us, so global players and also hidden champions, Volvo, Telekom, A1 Austria, Deutsche Bahn, DHL. Yeah, so everything you can read at our webpage. So why are you here? So I guess you're all here because you know that your business is changing. So while in the past, while we had maintaining big monoliths just by few bunch of IT guys in your company with 4 major releases in a year and with some fewer or less regulatory topics, it changed now. So you're now driven by continuously deployment, managing several services, which is done not only by some IT guys, but by cross-functional teams. So you're now engaged with several rollouts every week, month, or even day. And yeah, regulatory topics are becoming more and more complex. So that's why I guess you realized you cannot handle this the easy way. You need somehow to automatize things. That's the first point. And speaking about new regulations, also you have an increasing need for audits. So new regulations mean more audits to cover the topic. So do you have enough manpower? And do all the release cycles even allow you to audit them, to be completely audited? Yeah. And the other thing, can you even generate the new evidences you need to deliver to the regulatory topics and or to your customers? Because there are some regulations on EU level and in Germany, for example, like the DORA. So for financial services, you are required to prove that your operational resilience along the whole supply chain works. So meaning speaking about software development, also if you're a financial industry, also your supplier needs somehow to prove that his codes are safe, secure against attacks. And yeah, or coming from the critical infrastructure, we have NIS2 on EU level, you name it, it's transferred to local law, but even every EU country needs to take care about their critical infrastructure and therefore also assure the supply chain, for example, by S-bombs or just somehow strengthening the resilience and keeping the services up for critical infrastructure. So those are lots of topics in a small time. Sorry to speed it up, but we're really on fire. So in a conclusion, in a nutshell, there are lots of mountains to climb, and we suggest today we start with the software development lifecycle. That's why we are so proud to have Bill Bensing coming from overseas, so only an ocean away, like Sarah Brightman would say. And yeah, we can start with this little mountain here. And yeah, welcome, Bill. Stage is yours on autonomous insurance and governance engineering. Thank you so much.
That's a big round of applause. Can force it. We know we start with a good topic. We got to force everybody to. Yeah. But anyway, but everybody on the phone, thank you very much and welcome. Bill Bensing. Quick intro about myself. Some people may know who I am, some not. If you've read the book, you know I'm a co-author of Investments Unlimited. Also got a bit of a podcast called Control Freaks, where another author of the book called Agile Auditing, which, by the way, did anybody know that there was a concept called Agile Auditing? Yeah, I was blown away too when Clarissa and I first met and we started talking about this. So she's coming from the audit world, I'm coming from the tech world. So a lot of what you're going to see today is rooted in experiences since what? Ever since I started working, I've been in regulated industries. I talk about how I hacked the U.S. Navy, the regulated industry, just so I could pass audits, which that's a whole story I can't tell on this one just yet, but it was really fun. So going through that, and then at my time at Red Hat, working with the Department of Defense and financial sector, basically, but 3-4 years ago, that's when this started becoming a big thing. So a little bit about my background for the folks who don't know who I am, but I'm always going to start with my bluff. And my bluff is always the bottom line up front, which is the interesting thing. I'm going to tell you what I'm going to tell you in like 5 slides, and then we're going to dive deep for the next, I think, 80 on this one. We shortened it a little bit. So you should never, and when I say never, I'm saying never, ever, ever actually manually collect or verify your autonomous, your assurance activities. This is something that's done manual today, collecting evidence, people reviewing it, screenshots of people are familiar with that. What we are going to say you should do is you should autonomize assurance. And so why do you want to do this? Like this word autonomize assurance sounds really fun to do, but there's actually 2 business-driven reasons for it. And we'll talk about the first reason, which is one, this word 24/7 audit readiness. As you go through today, you'll learn this difference between assurance and audit. In the IT world, we like to use the word audit, but audit has a very specific meaning, and a lot of our time is spent in assurance. And so we're going to talk about being audit ready, and audit ready means at any instant, and when I say at any instant, within 60 seconds, an auditor can come in and basically say, prove to me you're doing what you say you're doing for the past 18 months. And within 60 seconds, you can do that, right? Number 2 is zero marginal cost. Now, I usually ask people to raise hands, but since we're doing a webinar today, I'm just going to sort of slide through. For those that are not familiar with the concept of marginal cost, say you're doing something for the first time, like let's talk about autonomous assurance. You set it up in your CI/CD pipeline. Maybe it cost you 25,000 euros, right? Now, the next time you run your assurance process, if it costs you 25,000 euros, the marginal cost to do it every time is 25,000 euros. The idea is once you do it once, every time after that, it's not 25,000 euros. It is close to €0 as possible. So the idea of the marginal cost is every subsequent time that you have to do something, you want it to be 0. And that's where it comes from. People talk about efficiencies and being effective. That's what we really mean when people say cost reduction. So that being said, usually this journey is a lot longer, as some people have seen, but I am going to ask you to take a bit of a journey with me. I want to define the words autonomous assurance and go through and actually explore the nature of the problem. And so why do we want to do this? Because 90% of the solution, or 90% of understanding how to build a solution is actually understanding the problem. So just take a quick journey with me while we go through, but I think this may be familiar. So if anybody's been here, here's my fun stick figures. It's that audit time again, right? So if anybody's been in this world, auditor comes in and says, hey, it's time to audit your processes. Usually they ask, tell me exactly how your process operates. And they're probably talking to a GRC person. And that GRC person is going to look to you as the operator or developer, and you're going to tell them exactly everything you do down to the nitty gritty details. Maybe have you document it, maybe you don't, maybe you video record and send it off to them, right? Of course, our GRC folks generally aren't fully technically inclined, and that's okay. But you know, they have to write it down. They have to do a lot of things with it. Then they basically go back to the auditor and say,
can you take the top box away so that our audience can read the bubbles?
Here.
Thanks.
You still sharing it?
Yeah.
Okay.
There's three.
Oh, perfect. Sorry about that. So the GRC person goes back and says, okay, I need dear auditor, I need three more weeks to do something. And then, here we go. And then not just 3 weeks, maybe 6 weeks later, all of a sudden the auditor comes back and says, hey, I haven't really heard from you. GRC person starts shaking a little bit. They're like, let me go double check on something. And then this is exactly where a lot of us come from. The GRC person comes to us. And what do we say? We're like, man, I told you many times how this operates. Get away from me. You're bugging me. And now all of a sudden, you got this GRC professional that's sort of shaking in their boots and don't know what to do. And they go back to the auditor. They say, we need 3 more weeks. And this is the problem. This happens over and over again. And this is why an audit can probably take 18 to 24 months sometimes. It's not just one thing. This is multiple processes. And so the problem here is we'll talk about today this concept of the 3 lines of defense. It is a collaboration problem between the first, second, and third line of defense. But also there's a universal truth to this is we keep throwing things over the wall. And this happens to a lot of processes. So if you think about how DevOps started, learned this from Damon back in the day. He's really one of the original people to help push DevOps forward. If a developer showed up to an operations conference or vice versa, an operations showed up to a developer conference, they're completely out of place. Like they weren't meant to be there. And so DevOps was about the universal truth of not throwing things over the wall. This is a similar problem here that we're talking about solving. So that being said, let's go and talk a little bit about autonomous assurance and what the terminology is. Now, what I've learned here is the German word. I'm assuming many people that are probably listening maybe have some German. I don't have much of it, but the German word is Schlagwort, like that are the buzzword, right? This is not a buzzword. It could sound like it could be one, but we do have really specific definitions for it. So first off, let's just start with the definition of autonomy. This is a simple Google one. I like to pull it up because everybody uses the word autonomous, and everybody has different meanings for it. So what we're going to use for today is what do we mean by autonomous? Well, we mean free from external influence. And so what does that mean? That you're doing your thing and somebody comes over to you and says, hey, you should do this differently. Autonomy means being able to be like, no, this is how we're doing it. I'm in control of how we're doing it. So the idea of that. So you think about automation, right? If you push a button, somebody has to push a button. That's automation. But imagine if for the folks like around the Kubernetes world, when you just say, hey, deploy this and things get deployed, that's autonomous at the end of the day. And so Kubernetes does its job without you telling it how to have to do it. That's a bit the idea behind autonomous. Now let's talk about audits. Audits themselves are a form of validation. We use these a lot in the tech world as to talk about, hey, are you doing what you say you're doing? But it's actually a form of validating that you're mitigating a risk. So when somebody comes to audit you, they're looking at what you're doing and they're saying, hey, this risk, let's talk about software delivery. Say we're delivering bad software or vulnerable software, and we have some sets of controls against that. They're going to look and ask, are you doing what you say you're doing? But most importantly, is what you're doing actually mitigating the risks of putting vulnerable software into production? So it's a very big thing that we need to understand. And what does something like this have? Like we have these risks. We'll call it, a risk of A happening when B process runs. So a risk of vulnerable software happening when we run the SDLC process. And it's going to ask, did your controls? Maybe it was a CVE scan. Maybe there was some type of provenance check for a dependency that you had in there. They're going to ask, hey, did these actually stop vulnerable software from getting in and occurring? And you go through, they do the audit, and you realize, yes, what we're doing is actually preventing these bad things from happening. So this is the idea of validation. You can validate that these controls work. So audit is all about validating that a control is doing what you expect it to do. You can follow the letter of a control and always do it 100% the right way, but it may not mitigate the risks. And that's where audit is there to find out. So if you're doing something like, hold on, what you're doing is you're doing it 100% at the same time every time, but it's just not mitigating the risk. That's what an audit's there to do. So let's talk about assurance. Now, assurance is a little different. Assurance is verifying you're doing what you say you're doing. So we may say we're running a CVE scan. We may say we're doing this, and this is not what an audit is worried about. We're not worried about are you doing what you say you're doing? This is what assurance comes in. Assurance is, are you doing what you say you're doing? So something like this is, hey, did we do the CVE scan for this SDLC process? The developer's like, yeah, we did it. So the evidence says that our CVEs are, our high CVEs are equal to 0 for this. And so they can verify that they ran the process, but also there's an expectation behind assurance. Not that I just run it, but also do I have high, medium, lows? What are those criteria? We'll call them claims. So if we tie this all together for what is autonomous assurance, I got two little slides to talk about this. Autonomous assurance is the application of an assurance engagement. So the assurance, are you doing what you say you're doing and doing it free from external control, right? So you have this control. You're basically saying, here's what I'm doing. You're telling everybody what's doing it. And it runs basically as your business processes happen. Another one we want to look at is autonomous assurance. It is a codified specification. And of course, it's executed free from external control. But the thing is, it has to be 100% explainable to a disinterested third party. Now, this is a key because what we mean by a disinterested third party is some random person off the street. We'll just use this term. Random person off the street could be pulled in and say, I'm going to pay you 1,000 euros. Here's exactly what this team claims to do. Can you verify that what they say they're doing, they're actually doing? They're a disinterested person. They have no bias to whether the team is or isn't doing. It's very cut and dry. It's very black and white. So that's the thing around explainable to a disinterested third party. So as we talk about autonomous assurance, it's running free of external influence and somebody that can come look at it without bias and say yes or no. One thing I want to point out is there's a lot that goes broader into those definitions that we can always talk at a future date on how those got derived. But a lot of technical folks don't know this assurance stuff has existed since around the 70s and 80s with the International Auditing and Assurance Standard Boards. So long story short, back in the 50s, 60s, and 70s, everybody did accounting differently. A lot of people around the world came together and said, how do we verify and validate? How do we do audit for accounting? So these practices exist. They underpin a lot of the Institute of Internal Auditors. But what you don't find is you don't find your GRC world talking about this. It seems like the governance, risk, and compliance world does not know these exist, forgot they exist. But if you look at the GRC world, the background, they're always focused on some specific framework, whether it's ISO 27001, NIST 853. They're experts in that framework. But GRC, to a large degree, doesn't have an auditor assurance practice behind it. So this is about 1,200 pages of stuff that you put you to bed really quick at night. But if you want to talk about formally how to do that, and the reason why am I bringing this up is like as you saw Chris talk about, you have DORA and you have NIS2. Those high standards for assurance and audit are making their way into the IT world. And so as they make their way into the IT world, you want to be prepared to do this, and we can do this in automated fashion. So wrapping this up just a little bit, autonomous assurance from autonomous, free from external control. Assurance verifies you have an operational specification. So you have specified exactly what you're doing, and you have said, here's my evidence. Here's what this evidence is supposed to do. This needs to equal 1. This needs to equal yes. And then audit is validating the requirements. So once you prove you're doing what you say you're doing, an auditor will come in and ask the question, is what you're doing mitigating a risk? And you can just remember, you can always be doing something 100% correct every time, but it actually is not mitigating risks. And that's what the audit's there for. So let's get down to a bit of a solution around this. How are we looking on time, right? All right, 21. All right, let's get down to a bit of a solution on this. So let's talk a bit about a framework. Now, a lot of these frameworks and things exist out there already. What I'm going to show you today isn't just something that Bill came up with overnight. I was actually inspired, like you saw, the IIASB. There's people who have these frameworks out there, some from the GRC realm, to start to show. But again, it's not really connected to each other. So there's two important people in the GRC space that I really respect. One is the Secure Controls Framework. I highly recommend checking out. It is actually open source, but the idea of a secure controls framework is this idea of a common controls framework. So you have a set of common controls, and they've mapped 200 and some odd other control frameworks to it. So the idea is if you meet this control, you can map it to ISO 27001, NIST 853. So you can basically use a big matrix to say, what do I need to meet? How do I need to meet it? I like their little layer cake because people will talk about policy as code. And I won't get into the argument today, but I'll argue there's no such thing as policy as code. Now, people don't like it when I say that, but the reality is when you go into the audit insurance world, policy is not a very small thing you do. Like, is my issuer this, from this URL? Policy is a high level expectation or objective. So it is vague by nature. It underpins what you do. And that's why I like the secure controls framework, because it's based upon policy, control objectives. Then you start to get into standards, guidelines, and procedures. OSEG is the Open Control or the Open Compliance and Ethics Group. The term GRC actually came from these folks in 2002. But they have this idea of a control activity and control actions, and they define them. And so why do I like these? Is because when we put them together, we'll put them together in a second. Let's talk about these three people. Talk about three lines of defense, internal auditors, GRC pros, and frontline employees, probably like most of you. Here's how you sort of fit into these frameworks as they exist. Your third level people worry about policy and control objectives. What do we need to do? The risks we need to mitigate. Your second and first line, once basically said, here's what we need to mitigate, here's a control we need to use. The second and first line are supposed to work together to figure out, okay, how do we implement this, right? So think about control as a requirement. It can be implemented in multiple ways, but you have to figure out an implementation to meet that. And then on this side, the control activities, this is where the front line comes in. So this is where you're affected. And then when you put this all together, this is what it sort of looks like, this big graph. So you can graph exactly what you're doing. So the control action is probably what somebody referred to as policy as code right now. Does this field equal this? So as I'm going through, I do a CVE scan, right? Does my CVE have 0 highs, less than 5 mediums, right? I can have up to 10 lows, that type of stuff. Just asking that one single question for each one, that's considered a control action. Your control activity could be vulnerability and weakness scanning, or vulnerability and weakness scanning. Your procedure right there could be your SDLC procedure. And then it's going up to other standard back into the policy. And the policy could be change management, or it could just be the control objective, could be ISO 27001, their control for change management. So that's how this ties together. Now, this is the number one problem we have today, if you guys haven't seen it, of when you get asked, what are we doing? Sometimes it's very ambiguous. Someone may give you, or it's ambiguous to say, are we doing what we say we're doing? That's why we have bad times and long times auditing. And so you get pulled out of your desk for weeks at a time to try to fill out this graph. And then 18 months later, this happens again. So as we go through this, showing where everybody sort of falls in this, your third line people fall there. Your second and first line people fall here on standards and procedures. It's important to know you from the first line, you also have influence on sort of the standards and the procedures and how we operate. The reality is these guys understand how to mitigate the risks and understand what control objectives need to be used. GRC has a little bit of deeper technical depth, but the first line developers and operators, you know exactly how to make it happen. So you have to be part of helping to translate this. And that's where how everybody comes and plays inside of this. So let's dig deeper into this control action, because what you see here is everything to structure to basically say, here's what I'm doing. So this is a way to structure to say, here's what I'm doing. But we haven't really talked about how to verify that you say you're doing what you say you're doing. So this gets into, let's just look at one control action. Inside of audit, there's this concept called a test of detail. There's higher thing called substantive testing the substance of something. So a test of detail is one individual, think it like a unit test almost. It's similar to a unit test, but we'll call it that way, or one behavioral test, where it goes and looks at a piece of evidence. Maybe it's your compile report. Maybe the evidence is you're looking at your JVM configurations if you're using Java, or your Go compiler configurations. That's your evidence. Then you have facts. Facts are the things in there. You're looking, for example, let's say it's your CVE scan report. You're looking for that one fact that says how many high CVEs I have. And then you're basically saying there's a claim in here that says that CVE is equal to or less than 0 for highs, for example. Keep using that one, right? Evidence, fact, and claim. Now, it claims specific because it does something. It says I pass because, yes, I am having 0 or less. I fail because I have greater than 0. Or there's this concept of inconclusive. And this is very key because somebody the other day asked, well, why is it not only just pass and fail? Why do we have inconclusive? Well, for example, let's say I didn't get the evidence in there, right? I can't tell you if I passed or failed because I just don't have the evidence to support so it's inconclusive. Let's say I have evidence, but I can't find the field for CVE highs. Well, I can't tell you that I passed or failed because there's no fact just to establish what happened. So therefore, it's inconclusive. Now, inconclusive is key because as you start to build out these reports to show that you're doing what you say you're doing, things can change over time. And if all of a sudden things start going from passing to inconclusive, that gives you an idea that this test of detail has a potential problem. And what is the problem? It could be one of these three things. Something happened to the evidence. The fact was mixed structure now. The fact has changed. Therefore, we can't make that claim. So with that being said, today we'll talk a little bit about NAPE. It's an open source project. The idea of NAPE is that you can codify all of this and run this autonomously, and automation runs autonomously through your systems. This is different. Assurance is different than policy as code. So certain things like when we deal with like, for example, open policy agent. If you guys don't know the history around it, open policy agent actually started out as a way to verify OAuth tokens inside of for API calls. So that's really how it started out, which is why Rego is very focused on assessing JSON at the end of the day. Very good tool to do that. But that's like, for when you think about it from that perspective, that's control, right? Now, there's other evidence that can be generated by that when you provide assurance, that you could do an assurance engagement and say, okay, is every single time I send an OAuth token through to the service, let's say your Rego says the issuer must be from CROZ.net. And every time I send it, if the issuer is not CROZ.net, it's hopefully it's rejected, right? And there's evidence generated when it's either accepted or rejected. Something like NAPE would take that evidence and then evaluate it. Because you remember, the system that does the controls from an audit perspective should not be the system that monitors itself. So this is sort of, if you think about it architecturally, an actual layer of an assurance layer across all your different tools. So they'll go and provide the controls and the stops. And this thing just collects the evidence and tells you back, sort of from an independent perspective, are you doing what you say you're doing? And so that's how some of these things play together with control enforcement versus the assessment of the control enforcement. So let's talk about life with NAPE now. Once we have NAPE in place, imagine all this is codified, and we'll show you here shortly what it looks like for it to be codified. Auditor now comes and says, hey, it's time to audit your process again. So we remember that big old painful thing before. Well, here's the new life of the auditor. Notice that second and third line aren't even in there right now. Once we've codified it, and we're automatically collecting it as part of our business process. So say you do a deployment to production, that CI in your CI/CD pipeline, you're collecting the evidence, you're analyzing it. They can now basically go to their computer and say, hey, it's time to audit the change management process for ISO 27001. Let's go look at these historical 100 deployments, right? And so what they're going to happen is they're actually going to go ahead and it's going to give them back everything. The evidence, the claims, whether you did pass, fail, or inconclusive, and exactly how it was evaluated. So they're going to, all that rigmarole, the audit and the assurance practice does not change. It stays 100%. The practice stays the same. It's just the implementation changes now. They're going to go through, they're going to be able to self-service to a large degree, and they're going to be able to look at this and say, hey, can I get all of the data? And then, of course, a lot of auditors who see this like, wow, this is perfect, because we'll go through the steps of an audit here in a second. But they spend a lot of their time doing two things in 4 processes. One is collecting all of this stuff and understanding it. And 2 is trying to explain it in a report. We'll talk about reporting because reporting is less factual and more political when it comes to some auditors. And so we'll talk about that here in a second. But as they get this, the idea here is you can do this without disrupting business. So imagine you don't have your second line, you don't have your third line in here. You as an operator or developer, if you get tapped on the shoulder, it's truly because there is some extenuating circumstance for you to get involved with. Now, part of this as well is, let me go back to this one right here. No, I don't have that slide in there. SDLC is one of them. Now we start thinking about DevOps and DevOps value to a business. We start thinking about breaking down walls. SDLC is a form of a business process. Now think about all the other regulated processes that you have in your organization that need to have assurance put behind them. It could be HR process, it could be HR onboarding, it could be some type of third party. So let's think about software supply chain, for example. Third party risk management, right? Maybe it's not a dependency, maybe it's a software as a service. We can write a script because everybody always asks for some type of report that's coming. If that report's fairly standardized, now we can write an assurance approach to start looking at those all the time. So if you're responsible for your software supply chain, there's the idea of provenance. I know where I'm getting it from, but there's also the idea of pedigree. And pedigree is, I'll use the analogy of a dog. So say you go buy a dog. We'll talk about a German Shepherd since we're here in Germany, right? Pedigree is asking the question, is the mom a purebred German Shepherd and is the dad a purebred German Shepherd? And you cross that back, right? So it doesn't matter where the dogs came from breeder A or breeder B. You're asking the pedigree, do they have the right pedigree? So is the dog that I'm buying a full-bred German Shepherd? So understanding where it came from versus the pedigree are two different things. With something like NAPE and autonomous assurance, you could actually now codify an evaluation of the pedigree itself from a software supply chain perspective. So with that being said, let's go into the 4 phases of the audit real quick. Out of curiosity, for all the technical people in here, who knew there were 4 phases to an audit process? I'm seeing shaking hands. And I can see people on the video right now not raising their hand either, right?
Nobody raises.
So there's actually 4 steps. Let's go through this. So when you get caught up in an audit, there's 4 steps. There's planning, fieldwork, reporting, and follow-up. Planning is exactly what it sounds like, planning. So literally every 18 months, somebody says, what in ISO 27001 do we need to review? And who do we need to talk to? What do we need to look for? The thing about planning is it happens once, but when it happens again, it's like rediscovering everything all over again. Think about all that waste, right? Then we go to field work. That's when they're tapping on your shoulder saying, hey, can you send me screenshots? Can you send me this? And it takes all that time to get back and forth. Once field work gets done, this is where reporting happens. Now, reporting is an interesting character because they're going to take all that. They're going to do a factual analysis, but nobody in an organization ever likes to be told they're doing something wrong when they're doing something wrong, whether it's right or wrong. So what happens is they spend a lot of time politically sort of wording this to be as objective as possible and say, here's what's happening without offending people. And so this is actually, when you if you read Clarissa's book, the Beyond Agile Auditing, reporting is actually one of the biggest time sucks there is for an auditor because it's that fuzzy stuff. Now the nice, and we'll talk about how we affect reporting there, but then there's follow-up. So then there's always coming to you and saying, hey, we need to do this for this control. And then they bug you for 24 months afterwards until it gets done. So how does this change? In the planning, the idea instead of with the old one where there's long time horizons that people are forgetting, now that you've codified stuff, there's nothing to forget. You think about organizational forgetfulness, it's codified, it's there. We don't need to rediscover things. Our plans can focus on what's happening next and what's happening new, right? With the fieldwork aspect, as it's happening as part of your business process, you're collecting and you're doing the assurance process, fieldwork basically goes out the window to a large degree. In the audit world, we'll talk about sample versus population focused. Let's say you do 1 million deployments, but they only sample 30 because that's all the manpower they have. 30 out of 1 million is not a statistically significant sample. So you could be doing a lot of bad things on accident, and the probability that they get caught up in the 1 out of 30 is very low. So what happens is you start to scale, you become very ineffective with your the audit processes because you don't have much manpower. And so the idea behind this is as this fieldwork happens, it's 100% autonomous, happens as your business process executes. And then humans get involved in a different way. So you can look at your full population to actually creating like the test of details as opposed to going through the manual redoing. On the reporting side, this is what happens here. And traditional reporting is time delay and sample focused. But what happens is when you have the computer telling you what to do, I mean, look at ChatGPT and AI. Anybody will believe what a computer says of what a human says. so if you got a dashboard with a report, people are going to believe that a lot more. And so what happens is you still have a bit of politicking that will go on and play for the newer stuff, but you can get rid of a lot of that argument about what happens, just being like, it's codified, it's here, you agreed to this, it's literally written down. So if there's an argument, we can talk about what we need to change, but there's less about did or did not. And then follow-up becomes different. As we start getting through here, one thing people who have auditors and other GRC bugging them feel like is just like 2 other lines of management, trying to manage them to do things. And so the idea here, and we'll get into this concept of governance engineering, is now this can become co-creation, hands-on work. So turning the GRC individuals, some of the internal auditors, into people who help create things like tests of details and some of these structures that you can use inside your organization and reuse. So they're just being another person asking you, sending you something on Jira or whatever you use to do all these other tasks. So at the end of the day, the 24/7, it's rooted in the assurance practices. 24/7 audit readiness and zero marginal cost is based on assurance, because if you can't prove you're doing what you say you're doing, then it's very hard to prove that what you should be doing is mitigating the risks that you need to mitigate. If that makes sense, there's a lot of should, woulds, and coulds there. Having a clear framework from policy, this high level fuzzy thing, down to pass, fail, and inconclusive. We now have that. This gets down to the 1, 2, 3, the codifying the assurance. So between the first, second, and third lines, Now we can break those barriers down and we can codify. I mean, we're here in tech. Think about a contract. It was a contract. It's a written way of how we communicate. Fundamentally, what we're doing now is we've created a contract around how we do assurance. And the whole thing is the computers can autonomize the actual execution. So no more field work and that kind of stuff. Do you have to be going in and reviewing this type? So that being said, let's get to governance engineering. I know I'm going through this quick. I usually don't like to just, but we'll take questions.
You're doing well.
So what is governance engineering? It's another one of those Schlagwort type words, but it's not Schlagwort. The idea of governance engineering, we'll talk about 3 lines of defense, is looking at your governance process as a system. And a governance engineer is something to think about like a lead engineer that's not just technology, they're looking at how the system operates. And they're tweaking things. Toyota used to have the concept, and I think still does, of a lead engineer. When you think about things like value stream maps, the responsibility that the lead engineer, they're an individual contributor. They didn't have people reported to them, but they looked at the whole production line from start to finish and looked at the bottlenecks. They looked at the waste, and their responsibility was to optimize that whole line, regardless of what section it was. The idea of governance engineering is that maybe they applied technology somewhere, maybe they didn't, right? So the idea is you can do this with or without technology, but it's the idea, and this doesn't exist in most organizations right now, is to look at that process system-wide and start to ask the questions, where do we need to change it such that we can create these, these 24/7 readiness and our 24/7 audit readiness and 0 marginal cost outcomes. We talked about the 3 lines of defense earlier. This is a common model in internal auditing. I'll cover this. This is a good model. So for example, your first line is like your hands-on people. Your second line, they monitor what the first line does to basically keep you honest. And then the third line is generally your internal auditors who are independent of any execution. And they're looking at what the first and second line does because they got to answer to like the C-suite or the board of directors who have these risk concerns, asking, are these people doing, what are they doing? Is it mitigating the risks that we're concerned about? So that's the 3 lines model. It's a good model. The problem is we have an implementation problem in a lot of industry. And so let's talk about how we can accomplish this with governance engineering. Well, where do governance engineers sit? They sit really between the first and second line and the second and third. So between the first and second line, what they tend to do is they're action orientated. So as a developer, you may go to these folks, and we'll show some use cases here in a second. And basically, like, we got this new control, or we got this new thing, this new CI/CD pipeline, or whatever it may be. Can you help codify the assurance aspects for this? So maybe we've done all the Rego, maybe we've done OpenSCAP and everything. We just need help to codify the assurance procedure for this. Something like they would do there. Between the second and third line, they're more communication orientated. So they're basically resolving some of these problems. They assist the second line with structuring some of the information so they can report it out to the third line. But that's what the governance engineers are there for, and they're systematically looking across the whole process and tweaking it as necessary. So for the folks that are fans of the team topologies, this is just sort of where the governance engineers fits in, from the different operation models to the different types of to the 4 types of team. They are generally not a streamlined team because they're not really delivering a product. But they either enabling complicated subsystem and or generally platform team. Probably most likely for you all start in a platform team. And then there's a thing I wrote years ago about governance as a service. But they'll start with there. You can either provide it as a service or have a collaboration model. So before autonomous assurance and governance engineering, you sort of have this little thing, right? What do you do on a daily basis? What's going on here? And the developers eventually like, why am I just want to get my work done? After governance engineering, here's what's happens. You have sort of your first and second line coming to the teams and saying like, hey, we got a new control framework. Can you help us codify the ways to do assurance for this? And governance engineering teams like, yes, we're going to help you. The other ones like the first one is like, hey, we're being asked for evidence to provide this business process. So say you're now expanding your value proposition throughout the organization, say it's the HR. As the governance engineering team, can you help us codify the assurance for this? And then from the third line people, there's this idea of control testing. So the idea of control testing is basically saying, okay, does this control mitigate this risk? And this is actually like a little sampling thing. They can take the evidence, change the evidence a little bit, or rerun the process to see like a sensitivity analysis. If I change certain things, how do I still mitigate these risks? So this becomes one of those things also the governance engineering help is around how do I do predictive, prescriptive and descriptive analytics. For the folks in the data world, there's something called audit data analytics that's been coming up over the past 3 to 4 years. Right now, it's more of a heuristics and sort of statistics-based process, looking at accounts on financial statements and looking at average, sort of like building the statistic of the average spend, and if somebody's outside of like a sensitivity range, then being like, let's go look at that. This is now a form of audit data analytics as well. This is less stochastic and more deterministic, because we're saying we can basically say, here's what we're doing. Are we doing what we're not saying we're doing? So 24/7 audit ready. This allows, when all the substantive testing is done, the auditors can come and go do their roles. Then with zero marginal costs, every time we run this, we don't incur the $25,000, or like even if it's 15,000 euros next time, it's reduced, but we want it to be close to zero. And the thing about autonomous assurance for the front line is you now can more focus on what you're doing and what you're writing. So with the governance engineering, dedicated focus to the assurance, it's an individual contributor, just not another line of management. That's the big key. Is a lot of these C control frameworks with people adding more compliance people, it tends to be just another person adding a ticket to your backlog, telling you what you think you need to be doing, which is not helping. Also, isolated governance variability. As certain things change, then the teams can focus in that area without having the changes broadly affect other people. And when it comes to the continuous monitoring, you're going to see DORA and NIS2, when you do this, you've implemented continuous monitoring. If you're constantly, every business process, establishing whether you have passed, failed, or inconclusive, that's continuous monitoring. Now, what you do with that from a learning perspective is how you operate. And we've had some people know in source community talk about contributing things like Prometheus plugins and stuff like that. So, but you have a continuous monitor on what you're doing. And you can ask that question on a daily basis. What's the proportion of my processes that are going and failing? So with that being said, I was going to show a demonstration in NAPE, but I want to take a breath for a second, because that was fast for negative checkers, let alone.
It was really fast.
Wow.
Glad you made a short version, Bill. Thank you.
That's usually a 4-hour workshop. Any
You
questions?
broke it down in 45 minutes without even actually half an hour.
Yeah, and I got time for the demo. So,
Super.
any questions?
Maybe before demo, I'm curious, how do you see governance engineering fitting in with the concept of platform engineering? Because platform engineering is something that many organizations today strive for. There are a lot of initiatives already in place. How do we fit this concept into an existing initiative?
It's actually a good place for governance engineering to take a foothold. So I think if you think about a platform engineer, somebody has to deal with some of the compliance and governance aspects, they can start there using something like NAPE to say, okay, what's our golden pipeline for Java applications or Go applications or JavaScript? If you got a golden pipeline, start there and then ask the question, right, what do I need to be collecting and assessing from an assurance perspective? And how do I tie that to the controls? And so they can start there by, and they're going to learn what controls they're supposed to be, the work with GRC folks and understand those controls and to map them. But somebody can start there, their engineering effort, and then grow that out to all the other different golden pipelines as well, and the golden paths, and do it not just from the development. We are talking about SDLC here, but also your production environments. So for example, you could build a verified application, but you may not be able to deploy it into certain environments. So for example, think about like between dev, integration, and production. So this we've done this a lot for some highly sensitive applications. My assurance can be low for dev and integration, or for dev it may be okay to have something low. Like I may not care about CVEs in my dev environment because it's ephemeral and I may not care about this, right? But once it goes into integration, that's a more persistent environment. So I may be like, all right, I cannot have these types of CVEs, or I need less than 5 high CVEs. And then when I go to production, of course, it's 0. And so there's different ways you can do that, or you can look at the environment readiness. Before you go deploy, you can then run an assurance assessment of your environment and say, hey, are these ports closed? Are these ports open? Whatever those assessments are. So you just remember, because you have configuration management, doesn't mean the code of its infrastructure as code is actually accurate. This is like, I think this happened with Equinox. That was their, if it was Equinox, I can't remember the company, but I think it was Equinox where it was not the Nginx, but the Apache server. Somebody had accidentally done something in their IAC and opened up an insecure pipeline, which is how they got in and were there. So like they had infrastructure as code, but if the code is not right, then of course you quickly spread things. And so you can look at your actual systems in production, run the assessments. And now what you've done is you have this big proof that I built the software the right way, and my environment is, at least at this point in time, up to my expectations. So forensics, let's say somebody hacks you. You have all of this data to show, yes, here's exactly what we're looking for. And then you can start to answer, and then you can start to do those forensics analysis. Like here's what it was, here's the state of the configuration of what it was, and we can prove it here, not just looking at our code, our infrastructure's code. We can also prove it here through this assurance assessment. So that's where I look at from the platform engineering side there, and then that's how they can grow this out.
Yeah. And what is interesting to me is that traditionally the narrative was we are building platforms as a mean to make lives easier for developers, but now we have much broader audience.
Yeah.
Now we are making life easier also for internal auditors who are using the platform.
Internal auditors, but you're also reducing the risk for your C-suite and directors, right?
Yeah.
Like it's just be like, a lot of us geeks like to think the new tools people care, but the reality is not a lot of people be outside of the geeks care about some of these tools. What do executives care about? Revenue and risk. That's it, right? Yeah. Am I making as much? Huh?
Only our things.
Yeah, only good things, revenue and risk. And so now, like from a revenue perspective, like when you buy new tools, they don't like that because it reduces revenue, right? But from a risk perspective, now you can be like, hey, with this stuff, like I can objectively show you how we're starting to reduce the risk. And as you talk about the internal audit, now as you get internal audit and some of those folks on board and they start to see how their life changes for the positive, it becomes it becomes more organizationally focused instead of technically focused. Yeah.
Hi, Bill. I'm Reggie. I used to do GRC evidencing for a European bank in Asia Pacific. So, GRC is very complex, especially in banks. We have different dimensions. You have IAM, you have CHM. The topic that you mentioned, autonomous assurance, would only apply to the technical parts of CHM, IAM, and SEC. But there are certain assurance audits needs to be performed manually. Like in my experience, it's not just the pipeline that deploys, which is being verified by the controls, but background checks on the approvers of the pipelines has to be done as well. Doors of the data center needs to be evidenced. And then there's another complex one wherein even the internal auditors needs to be shifted because there's a concept of discovery. So in the bank that I work for, discovery is very important for them. Like auditors cannot stay static in that department. Now, how will it fit in the autonomous assurance concept?
Reggie, if you guys didn't know, I paid Reggie to ask. It solves it all. So let's talk about it from that perspective. Actually, the example I have is an HR perspective. So you collect evidence when you do background checks and stuff like that. You maintain that evidence, right? So you can write an assurance procedure to evaluate that. So imagine as you're going through your process, your business process. Before I deploy, let's look at my approvers, whoever touched the code, and let's go run an assurance, right? I can go point to the evidence where it's at, collect it, and evaluate. Do they have financial crimes? Are they murderers? That kind of stuff, right? I do this every single time, so you have that done there. So anything that's in paper, let's talk about anything that's digitized, can be assured. You can write something to make sure it's deterministically assurable. Now let's talk about doors. We actually have this example today. This works. And so you get to some points, and I talk about autonomous versus automated versus manual. So separate evidence collection versus evidence evaluation, the assurance engagement versus the evidence collection. So say you have somebody going around and taking a picture of doors. Do they have locks and that kind of stuff? So you can do that. There's two ways to enter the evidence. It's manual. Did this person do it? And is there a lock? Yes. So you have a picture of it. That becomes evidence. And now it's a form collection. Once the data is collected, most likely you have a lot of control actions, right? It's not just one, it's hundreds, right?
Yes, I used to deal with 470 controls for just one entity, and it varies depending on the regulatory framework.
Yeah. So once you collect that evidence, then all of a sudden you click that button, and now that you've written the test details, you can automatically evaluate it. But let's get down to some digitization. Maybe you just go through every day and take a picture of the door, and some OCR recognizes that it's shut, it has a lock, like whatever it is. Now you get to a digitization aspect. So by solving the automated, the automated is like I gotta push a button, right? The manual is like probably what you experience, take a picture, write something down, pass it on. Automated is like, okay, I'm gonna either collect the evidence or I'm just going to evaluate the evidence I collected that I digitized. The autonomous process is as your business process goes, I'm collecting evidence, I'm engaging in the assurance engagements, and then I'm issuing my report in the background. So all of that can be achieved with this, and I actually advocate to look at those areas. But it comes down to you have to look at how do I digitize the collection if it's not digitized, and if it is, where do I just get my evidence and how do I hook it into my business process? One thing we didn't talk about was the actual integration layer. So that's a deeper dive, but like Ansible, different things like that, UiPath, you can create integration layers to then trigger that kind of stuff. That answer your question?
Yes, and I have a follow-up. So regarding IT risk, so whenever people talk about IT risk, it's a yes or no. But in the financial industry, it's actually a number.
Yeah.
It's usually a number which is the ceiling of a group of controls. So it's not average, it's always the ceiling. So in my experience, there's a separate set of auditors that gives controls that their importance. For example, IAM controls have significantly higher risk scoring measurement compared to the lower CHM scores. Now, how is risk score calculated in autonomous assurance? Because executives in the company that I work for, their bonus is directly linked to the IT risk score. So they usually get mad at every quarter that, oh my God, point one at this went down. That's 100,000 down the drain.
Yeah.
That's a perfect scenario for us. We should discuss this.
Yeah.
We can build them a dashboard.
Actually, they have prior to their acquisition from a bigger entity. The CEO had a big LCD screen right above his desk where you have the NPS score,
Yeah.
the IT risk score, the financial score, and it has weighed on him.
Well, so I'm gonna fly you out to all the other conferences so you can ask these exact same questions when I talk about you can do that with this. Now, when I see you can do that with this, not yet. The next couple of iterations we're looking at when I show some of this here is actually a risk tolerance way to do this. So imagine collecting all the evidence, doing the assurance assessment. The assurance assessment is really did I pass, fail, or am I inconclusive, right? Or just is my claim. Now, think about from a risk, like you talk about it, it's 1 to 0. I can pass, I can fail something can be inclusive. For example, identity access management, that may be very high. So imagine now you had this thing that's sort of a documented way that says, as I look at this assurance, this can pass, and pass, but this can never fail, or this can be inconclusive but can never fail. Like when you sort of make those, so what happens is the assurances, as you know, is just be a static analysis of what the state is, and the risk tolerance is based upon the state that am I going to allow to happen. Now we can codify this. Once we codify the assurance and what those facts and claims are, now we can codify this. And to your point, like as business processes run, then you can have real-time risk scores, risk assessments, or two things. Say it's out of risk tolerance, somebody can sign off and that can then be tied back to the document. They can digitally sign off and say, for some business reason, I'm allowing this to go through, or it gets fed back in because a lot of the times things get stopped. It's not clear exactly why they're being stopped, and you have all that back and forth. But once this is all codified, you basically like, here's my risk tolerance, which is like 1,000 criteria. These 5 are the things that that made it go above the risk threshold. So that's not in here just yet. That's actually a near thing I'm working on. But that's what we want to get down to this is because a lot of people think this is subjective. It is when people are doing it. When I rely on Reggie, I feel like it's subjective. But Reggie's got the Reggie algorithm in his head. And it's just not documented down. So a lot of this is like, how do we get something like a Reggie algorithm on here or whatever the C-suite algorithm is on here, such that now Reggie's can be looking at and saying, what's the next thing from the this? What's my next control? What's my next? Can I be looking for the things that we're not looking for? Because we're spending so much time just doing all of this, you know, the boring, but just stuff to keep lights on. So yeah, so that's exactly as we look through this, like, did you think about this? It's not changing the process, it's changing the implementation. So we can reallocate where the humans actually do the work.
It's very interesting.
Well, thank you.
We used to have like a 7-figure budget just to do the evidence.
Deep 7 figures, 5, 6.
Yeah.
Oh wow, that's a lot of. Well, imagine the bonus you get if you were bringing this in and be like, you know what? If we're spending 8 million euros a year, I can do it 100 million. 100,000. Yeah.
Yeah, or he's doing it remotely.
Yeah.
Nobody knows that you use a tool for it.
You did. So it was it. What was it? That was the movie. maybe the Office Space movie, when the guy was collecting one penny on every transaction.
Yeah.
Man, he got really big. No, right. Here, the other questions though? Those were good. Hey, that's awesome. Somebody with the background.
With these amazing questions and little better answers, we will conclude this webinar, this online session. So feel free to join us in the conversation afterwards. We will say hi to guys in
I
the
think
webinar.
Bill wanted to do some demo.
I could do one if people have time. I know we're at time, but I
Yeah.
can do it tomorrow.
We can, yeah, we can continue for a couple of more minutes and see the demo.
I'll do that.
If you want,
Prepared.
Sure.
it would be a preparation, right?
So it's not like I'm in a hurry to get home. I'm wishing away, right? Here, we'll do this then. So what I'm gonna do is I'm gonna change. Let's go to do keep sharing. So
It's usually time boxed and now we extend it.
so I am in. So we're gonna see some of the real geeky stuff right now. We're at 1.0 of NAPE. So I said we have everything over here. There we go. So we're at 1.0. I'm gonna go show a couple things inside of what something like this would look like. So the idea we're gonna see here's the NAPE catalog. Imagine all the stuff. Like generally, there's like a central store of documentation people go to. When that documentation becomes codified, this is an example. Imagine you had there's the Reggie's company internal repository for all the actual ways to evaluate, like to test the details, but also how to structure it. NAPE tutorials is just an example of one. We're adding more over time. The idea with this content in here is actually people can come and like if there's a new regulation that comes out and as we add content to it, they can just use it and start to have a place to start with or be inspired to say, here's what other people are doing. Here's what we should think about it. Let's go to that employee business process. So this is my new employee assurance procedure. So I'm going to show you what this looks like remotely right now, and then we'll dig into it a little more. Do you guys see that pretty well?
Yeah.
Dig into this. So it's 1.0. A lot of this is some of the geekish stuff behind the hood. We are going to be building facilities that are more attractive to less technically inclined people. One aspect behind this is we're getting involved with the LLMs, is we're trying to enable the line 2 people to actually write this stuff. So through LLMs, teaching on Python, Microsoft Excel, actually they announced ChatGPT and Python as a first-class citizen. As we go through the test details all written in Python, it's a very strict way to write it. And so the idea is we have these heavy guardrails so that somebody with that right macros can write this stuff as well. And it moves a lot of burden off the IT so that you have your actual line 2, because like biggest gripe from line 3 is that line 2 is, doesn't do quite their job. So as we go through this, here's an insurance procedure here, bit of an API, some data around the procedure. In our instance or name resource name. This is a unique name that describes exactly the instance of the procedure you're running. So this could actually be like your control process. This is just a new employee. And this is why I call it my new employee assurance procedure. This just verifies the new employee has completed past criminal history, required documents, all that kind of stuff, right? So for example, activity name, criminal history. We have a lot of convention built into this to where it's very easy for you and it structures it because it automatically collects everything. And does things like that. But this now comes in like, human description short. Criminal history is a short name. Description is activity verifies employee does not have a criminal history, right? So then we go to this action. And this action, we'll show what this looks like. But basically, in the framework, it's expecting a piece of evidence called background check.txt in this specific area. And I'll show you what that looks like here in a second. And what it's going to do is it's going to apply this test of detail. Right. So as we go through and we collect evidence, we basically collect a piece of evidence that says, hey, this is the background check.txt for verify no criminal history, right? And I'll show you what that looks like. And then this is the description. So this is actually describing how we're doing the assurance procedure. We're going to look for this piece of evidence. We're going to apply this test. And this is when this thing evaluates. This is what it is. Is that clear? Does that make sense? Okay. Same thing as we go down here, document signatures was the compensation agreement signed or not. So this is your centrally controlled procedure that's here. Let's now look at the test of details. I have a lot more up here because in the tutorial you actually add stuff. But for example, we'll go like verify, criminal history. So this is expecting a specific type of document. And what you can see here is that the evidence comes in and it basically is a big file inside of Python. And it's going to go find a section called criminal history. It's going to go down one line and start to look for like if the criminal history section doesn't exist, it's going to return inconclusive. It just can't find the criminal history section, right? So then if it does exist, it's going to look for a very specific term that says no criminal records found. If it exists, it passes and says the evidence contains the expected statement, no criminal records found. I'm going to stop here real quick because we talk about pass, fail, or inconclusive. It's not like a yes or no. What we want to do is be very descriptive on why. So the idea, and there's a bit when I talk about some of the stuff, is that disinterested third party, they're probably not going to dig into the code. They're going to look at the human readable report outcome. Human readable report better say, here's what we're checking for. And if it passed, why? Not just thumbs up or thumbs down. It passed because we found the expected statement that, no criminal records found in the criminal history section. It needs to be very, so when you think about some of the stuff you did from the audit and having to communicate to people, the idea behind this also, we have Thomas Assurance, is it has that built-in communication mechanism, and it's thought about as you create these. And like each of these procedures, you'll have thousands of these, but they do one thing only, is look for that specific, to assess that specific fact and make that claim. And then, for example, if no criminal records are found in the criminal history section, the evidence does not contain the expected statement, no criminal records. Does that make sense so far? So as we go through this is the type of stuff that's now in your central repository. So for example, for this new employee, we have a procedure and we have actually all the tests for each activity. So we have there's a bit of a convention. So you can start to see here. You see like when I go back to the assurance procedure, see how it says criminal history here is the activity. This is the activity that each of those under here are the individual actions themselves. And so let's now go run this, for example. So if I go back into here, and we'll go back to my tutorial. So inside my simple business process, what you're going to see is this is now, here's my raw evidence. Let's say somehow my background check information got here. However it did, right? I collected it automatically as a business process. Here's like my employee onboarding from the JSON system, right? As you can see, this background check is just pure text. This is something more structured like JSON. This from my LMS is more structured like XML. Right? So this is the reality is we get all these different types of data. So let's go look at how we execute this procedure. So this is some code that would be written, whether it would be in Bash or not is completely up to how somebody would do it, but this is the actual command line interface. So we actually start a collection process. We'll basically say, here's the subject we're collecting against. We're going to correct assurance on here. This subject ID there is like if I run multiple assurance processes, that's like an SDLC, that could be the build number. Now here's where we get really specific. Remember I just showed you all that procedure stuff? This is the link to the company repository. And this directory is the logical link to that folder that contains that assurance procedures and activities. And so the whole idea is I'm referencing back to the central one is every time we run it, we're going out and we're pulling all of that anew. We're not borrowing anything locally, we pull it anew every single time. And then from an extension point, you can start to use things like these meta tags to add other data. So I'll show you the report comes out, these meta tags transfer to that report. So as you want to run any type of other deeper analyses on did like this type of employee consistently fail or be inconclusive, that kind of stuff. So now I'm going to go and start collecting evidence. Collect evidence. We tell it what control activity we're collecting for. This is criminal history. And we just give it the file path of the stuff we want to collect. That's really just how we collect. That's how we collect this. We can collect the document signatures this way. This is how we're collecting the evidence. And so as we bring the evidence in, it's actually structuring an underlying structure that you saw inside of the assurance procedure file. So let me go ahead and just here real quick. Let me get into this. So inside of here, what I'm going to do is I'm just going to run this procedure. And once I run this, you're going to see here in a second, inside of here, a directory is going to pop up. Shoot, run. Perfect. We'll give it a second, we'll have to force it. So so this directory just popped up. This NRN procedure, what you'll see here is this has got a specific name that falls under your NRN. What we're doing, some of our next enhancements is, have you used things like Audit Board or Assure or Banta or Java or anything like that?
We used to have custom risk to
Customers?
Yeah, it's like the company built it.
Okay. So the idea we're having here is like with the command line interface, you can actually then send this as the insurance process executes. You can now send the actual report and all of the evidence and everything to whatever the target risk management system or GRC system that can collect this. And so here's what it looks like. When we open up this folder, you're going to see that it says activity. All of those little activities that we evaluated, we pulled these down. So when somebody goes back historically 24 months from now and says, what did you do? You have the exact code and you can rerun it against it to basically show you get the same outcome. We also collected the evidence. Notice that criminal history and the document signatures, we collected that evidence and we copied it into here. So the background check that was in our raw evidence was copied in here, right? Then after we did all that, we ran everything against it, and this report is what's generated. So inside this report, what you're going to see here is the assurance report. That metadata had in there, like employee name, we added the start time and job role. That stuff flows through to the report. The subject, who is being assured. So you can be very specific down to like, is it a person? Is it a specific run or something? You can get very specific. The procedure where everything came from. And now we have a summary. We have 2 activities. We have 2 actions. 2 actions ran, 2 failed. For example, we could have like 4 activities, but 2 could have failed. So what we'd see here is we'd see that when I say failed, it may not have executed for some reason. It could have a code of Python for some reason. And so that would basically come out as an error, right? It would come out as inconclusive. You can see here we passed because all 2 passed, we passed. We have some basic logic in here right now that says like if you fail, you fail. If you're inconclusive, you're inconclusive. And if everything passes, you pass. Very basic. But let's get down to each criminal history. So remember we talked about criminal history, verify no criminal history. Well, we ran that against the evidence, and it says, oh, the expected evidence statement says no criminal record found. Right? The test file. So we're actually pointing to where the test file you can find in this directory. And then from a non-repudiation standpoint, so somebody can't, if they modify the data, you would see it. We actually provide a signature. So from a provenance perspective, we provide a signature of that actual file as well as the evidence file. So if somebody really wants to go through, do some deep verification and be like, is this really the Python file you use to evaluate? And is the evidence that you've provided me really the evidence that's inside here? You can do that deep stuff. In reality, I think we know that generally doesn't happen except in forensic issues. And so when you start to think about the forensic capability of something like this, now you can start to answer those questions. Same thing with document signatures. You can see the sign. So we have a passing one now. Let's create a failing one. So what I'm going to do is I'm going to go into the raw evidence. I'm going to show you something here real quick. I'm going to modify this to non-delete directory. And I'm going to go into that evidence in a background check and has financial crimes. Right? So we just change that. Let's go ahead and rerun this. So I'm going to rerun this again. It executed. And what we're going to see here now, once it refreshes, give it a second, is when we go in here, you can now see we have 2 different runs in here. We have the one we did before, and we have the newer one. Let's go look at the newer one here. Let's look at the assurance report. And what you're going to see here is, oh, that's not the new one. This is the newer one. I now have a fail. Why did it fail? If I go down here into the look at the documentation, the evidence does not contain the expected no criminal history found, right? And so I can go look, so inside of here, I can go look at the evidence itself that we collected in the criminal history. And you'll see that what we collected was what we just updated. And you can see it's using between the 2 assurance reports. So if I pull assurance report 1 up, find the other assurance reports here, this other assurance report. We'll see if I can like, I'm not going to be able to do them side by side. But the idea is we can pull them up. You can probably go compare them. And when you'll see is you're using the exact same test file, but your evidence signature is going to be different. Yes, of course, it's a bitwise file signature. So if anything changes in the file, an extra space, whatever it is, that signature changes. They're technically not the same. So that's when you look at it that way. So you ask the question. Now, once you start to get the SDLC aspect, now you're just writing these styles, and we have actual LLM prompts. And what we're building out is a way that somebody can basically upload their evidence and basically say, here's our pass criteria, here's our fail criteria, here's our inconclusive criteria, and then these things are created for them, and then they can work with people who understand Python to modify it a little bit, but now becomes more clear as you engage IT what needs to be done. I'll stop right there if there's any questions about that. That was really, I know it's a really deep, thick topic. And a lot of first-time folks, this is a lot quickly.
About the pedigree.
Yeah.
I understand how this framework will help with the provenance. I'm not sure that actually I understood how the pedigree issue get captured through this demo. So it seems that actually with the pedigree, there is maybe a source or one of these criteria that has higher weight than the other one in order to then pin into fail, not a pass or inconclusive. Where do we see that part here? Do you see?
Let me make sure.
Clear my question?
Let me restate. So as you talk about the pedigree, the pass fail, how do we see? Ask that one more time in a different way. I think I understand, but ask it just one more time in a different way.
We spoke about the pedigree issue, and I wonder how this pedigree trait is captured into this demo. If there is any way to see, okay, these criteria has higher weight to then make.
I see what you're saying. So from the pedigree perspective, nothing here is weighted one over the other. To your question, nothing's more weighted. From a pedigree assessment, what you're seeing here is like, for example, if you go look at the evidence right here, when you ask the question, was like the mother a purebred German Shepherd? What is the evidence they were? When I talk about pedigree, it's all in here. So I can go look at the original evidence, and so I can assess it from that perspective. And so instead of just having a pass or fail, somebody saying yes or no, someone would be like, well, give me the mother's certificate of, the certificate of authenticity from the mother. And so that's proving the pedigree. So yeah, when you have it like is one higher than the other, that's not really in here. I'd be interested to understand like what use case you may be referring to, because that'd be interesting to see like, if you're looking at 3 different pieces of evidence, if there's 3 pieces of evidence available, and you can only evaluate one, do you pick one over the other? Is that sort of the example you use to say I have 3 pieces of evidence or something, and there's one is worth 0.1, the other one's worth 0.5, and the other one's worth 0.8.
Yeah, one would be more related to the case respect to all the other.
Yeah, no, we don't have anything like that interaction. I just didn't think about that. But that could be something that, that could be an extension point. That'd be interesting to understand from that. Yeah. So we don't have it like that, but I'd be eager to learn more. Yeah. Any other questions? That's good questions.
No more questions.
Cool. Well, thank you all for the extra 15 minutes over. And
yeah. Then it's my turn to thank all of you for participating. Ivan had to leave. You saw it. He had some important client meetings. So that's why we now close this session now at Zoom. Thank you for participating. And so we have coffee, we have sandwiches, network